Good morning, everybody. Thank you for giving me the opportunity to present in behalf of the group. I just want to say that we started only actually over a year ago, maybe 18 months, and it's a nice group. We have grown, at least the people's that they want to understand what we're doing and how the potential of using this type of technology has increased. We have the advancements that we have done, and I'll show you a little bit of how much we have advanced. Is low, but it's part of what is this type of technology or biomarkers that we're trying to do. So let's get started. Next slide, please. Um, so we have, again, we have a good number of industry, academia, and government that is involved and is part of these meetings. So that's good to have the diversity of thought. And we appreciate everybody who has been joining and participating in different ways. Next slide. So the overall purpose of our group, and you will see some slides that are a little bit repetitive, but I think it's important to kind of establish that we're trying to use these new technologies, error corrector sequencing, and see what is the potential if we can use them as an early biomarker of tumorigenicity. The idea of those technologies is to try to see if we can measure clonal expansion as this biomarker. It's not an easy task. But I think it is an interesting one, and that we should at least have the chance and the opportunity to look into it. Next slide, please. Again, I don't know if you have seen before in other presentations, but we're part of the error corrector sequencing. We're not the only group that is doing it within HESI. So we're the only one within the eSTAR, and our purpose is to do non-genotoxic carcinogens. Sorry, non-mutagenic carcinogens, while we have other areas of HESI that they're using it for, like the GTTC, that they're trying to understand mutagens, and in CTRACs, they're trying to use this technology a different way. But it's important to keep in mind that although if you use the error corrector sequencing concept in this talks in HESI, you have to also kind of qualify which of the projects you're talking is, because they're slightly different. Next slide. So, and I assume you have seen this before about the paradigm of what we're trying to do. How can we understand better or predict better the potential have liver tumors, and how we want to have biomarkers to do that. So Keith's talk a lot about these this clonal expansion or these transcriptions and biomarkers with that. And then what we're trying to do in our entity, we can get cancer driver gene mutations, and how if we can see clonal expansion of that can also help. The idea is to at some point try to validate both or have both endpoints as part of a way of evidence in order to assess tumorigenicity risk, and how are we with that. I know that the transcription is being actually much farther along. You guys have been doing this for a little longer and has a little more validation with studies. We're starting, but it doesn't mean that it's not a complementary on that big way of evidence about these biomarkers. Next slide. So I think a year ago, we put together what do we need to do. So we had just one first pilot study that we did, the PCB126, where we started with the principle that you can see clones form with these non-genotoxic carcinogens early on, and that has the potential to predict that. However, it was one study. And we know we need to do a lot of things to make sure we can apply those biomarkers and endpoints. And the first step was really to kind of understand we need to do more studies, we need to have additional compounds, and we need to really see how that works. So we're still in that phase, and that's what we're showing here. But I like this slide, so it shows that there's a long way to go, and we have kind of a path of where we want to go. The important thing here is that we're starting that path, and we're getting with that additional compounds and studies that we need to do. Next slide. So again, so this year, and I think it was a little bit end of last year and beginning of this year, what we put together, as we need to do 2-year CARSA studies, that they're not simple, and we're not planning, at least upfront, to do those studies. But what we wanted to do, we went out there and we scoped how many samples people had in the freezers that we could use, because what we needed to use is very specific type of sample. So we need to have samples that they have a 2-year CARSO study that are positive through a non-genotoxic mechanism, that somehow they could have samples early on, that they have samples or 3-month samples, 6-month samples, or samples early on that we could use to see if we can actually detect those clones. And that's kind of what we did. In the first box, you can see that we identified a couple of studies that had those characteristics. And then we still think we are still, the second box here is showing about technology swap. So with the error corrector sequencing, the first technology we were looking at is DNA duplex sequencing, but we know that is not the only error corrector sequencing. So we wanted to see the other error corrector sequencing, and that's still on the dock to do those samples exchange. And then with the third bucket that we're thinking we need to do is, can we or should we do next experiment? So we identified within this that we have these available samples from this group. Syngenta actually provided the samples. They had imidazoline analog, and they had a very nice set of samples that we could use. So that's kind of what we're going to be our pilot study based on the following characteristics. I think if you go next slide. Next slide. So why we thought the Syngenta study was good for us. First of all, it met some of the criteria we needed. It was a non-genotoxic. It was clearly negative in the gene tox battery. It had a CAR activation mechanism. They have done studies. It had done the carcinogenicity study, the 2-year CARCA studies in rat and mice. They have seen hepatocellular carcinomas. So that was kind of check. But the lucky part for us is that they had already also run a short-term toxicity study. They had a 90 days with the same compound, and they had samples for male mice treated with this compound. And they had seen already some type of changes in like this hepatocellular hypertrophy and liver weight changes in those animals. So they were the key samples. So once we identified that the study worked, we have to actually work with Syngenta, we're thankful for Syngenta because we're able to provide the samples and we're able to actually use them. And that's kind of where we selected that liver samples that we have there. And if you go to the next slide, please. So then the pilot study, then we started asking a couple of questions, and they were critical tactical questions, like who's going to do what. So we needed volunteers. We needed people who actually was going to, besides getting the samples, which is a big deal, we needed people to get the tissues, to be able to do the libraries, to do the sequencing, to do the analysis. And within the group, we had a couple of volunteers to do that. And then the initial discussion we had as a group, it was, in the previous study, in the PCB126 study, all of the samples were done by punches. But there was this kind of thought, what happens, do we really need to do punches, or could we just homogenate the tissue? So it became that to be one of the main questions that we wanted to answer, not only because of our study, but we linked a lot with the GTTC error corrector sequencing. So we want to keep track of what they're doing. And there were also thoughts about there about homogenate and how to do that. So we decided that for this first pilot study, we wanted to not only understand, can we detect the clones, but can we also have other questions asked, like, do we need to have the punches versus the homogenate? And fortunately, they were tissue enough that we were able to kind of use it and make that as part of our study. So if you can see in the right-hand side, the idea of the study design was, we had enough liver, so we had created criteria of how we can make punches of those livers, and then how we're going to get a homogenate. So that was the first purpose. Then we were going to only use the vehicle control animals and the high dose of the male mice, as we knew already they were in a dose higher than what they saw the hepatocellular carcinoma in the 2-year CARCA study. So we went ahead, and that's kind of, we were starting to do our pilot study. Can you go to the next slide? I think you can just put it along. Thank you. So the principle, once we got started, and I have to say this area of work was done, or is actually currently done by University of Ottawa by a postdoc, James Alper, in Carol Jog's group. He had actually volunteered to do this study, and what we wanted to do is, even if it's the punch or the homogenate, we were going to use the duplex sequencing kits that had the cancer driver genes already selected based on what was done with the PCV126. And the idea was, okay, let's go ahead and let's start. This is not an easy process. There's a lot of samples, and I know if James is on the line, he can at some point just kind of relate how much work it is to do that. Especially if you think about it, we had 10 animals per group. Each animal will have one group will go into 3 punches per animal, and then you have the other that homogeneous. So this was around I don't know 80 or 90 samples that they needed to be analyzed, and which he did very nicely. So, and again, the mouse panel that we use with the same mouse panel that was identified as part of the PCV126, what is, if you can see in the bottom part of the slide, it really has 27 cancer genes identified, and that's what we tried to target. You go to the next slide. So this is just to kind of relate of what James have done so far, meaning this is a lot of samples and you had to do a lot of homogeneous versus punches. And we wanted to understand the first thing also was the performance, because not only we're doing all this pilot study, we also do technical pieces, also doing making sure we can transfer that technology has only been done for these cancer driver genes, was only done so far, it was done by TwinStar only, and by doing it now in health so in the University of Ottawa actually also help us to understand this transfer of technology question. And with this performance of all that many samples that were needed, show us that it can be transferred, it can be done. And actually, if you have a person that has a good lab skills, can get done very well, as James demonstrated here. And as I indicate here, some of these slides are from James, so I wanted to make sure I acknowledge that he put together these slides. Next slide, please. So where are we so far? I know we have not done a lot, but this is a lot of work. So we got the samples early this year. We were able to send them and identify the University of Ottawa. James started working on those samples. I don't know, it was actually late when we were able to receive the samples in Canada. I think it was May or something like that. And then James very quickly tried to do the libraries. He did initially a small sample set just to ensure that he could do them and work well. Once that was identified and done, then he went and did all the samples. And then we had to identify a group that was going to be able to do the sequencing. That fortunately we had Sultan from Merck that was able to do it. That Sultan sits in Keith's group. So we were able to do that. And we just recently actually got all the data. And the data analysis got started. So Meagan Mayers, who is my co-chair, she has put together a working group where they're trying to kind of think and analyze the data. And the purpose of that working group, and I think is key, is like the data of these cancer driver genes and this mutation clonal expansion is a little different than just regular mutagenesis. So it needs some thought. It was originally done in the PCV126 by TwinStar, and actually they had a very nice workflow of how to do it. But I think we want to use these samples as an opportunity to follow up that flow and also have others come up and see, is it the only way to analyze the data, on how different ways we want to analyze the data. We want to make sure that we are using as much as possible all this information we're getting from this study. So this group actually started, they met a week ago, and we're still in the process of forming the group. So if people interested, bioinformatics people, statisticians, it would be great if we can get that. But I wanted to say thank you, because although it seems to here is just kind of some couple of bullet points, they're very key bullet points, because the amount of work behind all these different aspects are very important. So I wanted to keep and shout out and a special thank you to Stefano, to James, to Sultan, and to Meagan. Next slide, please. So where are we? Just so you guys get a sense. So we are in the data analysis pieces, as I mentioned. We will try to see if we can get that initial analysis done by GTA. Those who don't know, that's Genetic Toxicology Association meeting that happens around May here in the US. It's just milestone because that's where some of my people from our group goes, but it's not the only place we're going to share it. But the idea is to have that kind of looking forward, that the milestone we want to do. So that's kind of where we want to go. So you guys have a clear vision of when we're going to get more data so we can discuss. Can you go to the next slide? So what are the next steps for us? So we still need to complete this pilot study. As you can see, and I tried to relate to the presentation, there are different things we're trying to target at once, and I hope we can do that. We want to continue to look for more samples and more inventory. So we still shout out for people out there, do you have studies in your freezer that we could use? I think it would be great if we can do that. One of the challenges we had this year, and I think a lot of you may have known, that we were using duplex sequencing. That was a technology from Princeton. Princeton was closed. So that technology, we're still trying to understand what is going to happen with that technology, and if that technology is going to be bought by other company, continue using it, or we might need to go back, and there are other error corrector sequencing technologies that are coming out there, and we might need to go start looking into other technologies at this point. We were planning to do that, but not this early. So that was part of our process, original process, but not this early. But that's something we need to keep in mind based on the availability of the DNA duplex sequencing samples, as Princeton is not anymore doing it. Other things that we want to put out there is funding opportunities. Do we think at some point we want to do new studies? And that could come, and that information or that thought could come from what is coming from Keith's group and Chris Corton's group. It would be good to know, is any information there from some of those already know non-genotoxic carcinogens that we would like to understand a little more. Maybe we want to go and do a small study. We cannot do a 2-year CARSA study, but potentially we could do a transgenic 6-month study and get samples along the way. I don't know, there's some thoughts out there, but if there's any thoughts from the groups that they want to do something else around that clonal expansion concept, it would be great that it can come to the group and can be discussed. And again, so we will want to make sure we can still eye on these other technologies and how we can collaborate and do that. Next slide. So I gave a high-level overview of what we did this year, as mainly to keep this group informed of what has been accomplished, to make sure that people who have been done the work also get acknowledged. And I want to just open it up for questions.
Really nice job, Patricia. Thanks for walking us through a lot of work. Yeah, folks can either unmute and ask their questions, raise hand, or put in the chat. Or if there's anything, Meagan, Carol. Oh, Chris has a question. Go ahead.
Hey, Patricia. Yeah, thanks for that. I appreciate all the work that is going into this project. But taking a step back, it would be good to know, the difference between an exposure that may activate a bunch of receptors that, if you hit them hard enough, they will cause cancer, versus a tumorigenic dose. So this is the same issue that our group is working on. In other words, defining thresholds that then trigger the occurrence of tumors. So in the study you just described, you've got one high dose that is high enough to cause tumors in male mice, it sounds like. So are there plans for looking at lower doses so you can actually see what is it that defines the threshold? Yeah. What is the difference between something which is, not tumorigenic and something which is tumorigenic?
Yeah. Thank you, Chris. Sorry, my camera, I don't know, stopped working. It's not that I didn't want it to see you, but I don't know what happened. So I think that's a great question, Chris, and that's kind of where is really the issue that we have to identify that threshold. That's one of my main concerns of making sure this technology is understood before we apply it anywhere, because that threshold makes a big difference. The goal, yes, we had the other samples and we have the other samples available. We have not done it yet because we thought first, we have so many other things we wanted to try, like the punches versus the homogenate, that we thought we need to go to the high dose just to see, can we detect anything? And if we can, and we can find how it works, then we can go lower in doses, and we have availability for that. So yeah, that's kind of the plan, but it will depend on the results of this first study. Because another thing is, think about it, we have a 2-year outcome and we're seeing samples of 90 days. Is it a right timing to look for a clonal expansion that has the relevance to form a tumor? We don't know that. And I think that's something a lot that we need to think also about that. And I know there's some studies out there that they're trying to see all other timelines, not only like 3 months, but a little later, not necessarily that 2 years. And that would be great if we can get those samples, those data at some point. Yeah.
All right, thanks.
Thanks, Chris. The only other thing I see is a very well taken comment from Carol in the chat. So this is a really nice time to get involved, especially for the data analysis. One thing we discussed, we had a call last Friday, is kind of power and how to determine that. And having a statistician would really help us. So that's a call for you and for your networks. If there's someone who wants to get involved with the data analysis of this, it's ready, and we have a really nice video where Meagan walks through all of it. So call for that.
Okay.
Okay.
Okay. Thank you.
Thank you so much, Patricia.